Okay, so we're live, yes. So section 1.3 picks up where section 1.1 left off. I mentioned there's kind of a weird sequence in this chapter. So we're going to review some of the ideas and extend them a little bit. So I asked everyone to create 3 different plane figures and then describe a little bit about them with ideas from section 1. So I'm going to start off with my 3 figures, and I've got a couple different versions of them. I have the screen version, then I'll show the real life version in a moment. So what would some words you use to describe my first figure here? Regular, triangle. Oh, my pen tools went away. I'm back. There you go. Okay. It's triangle. Blue here. Triangle. Regular. Remind us, what does regular mean?
Equal, angular, and equilateral.
Yeah, equiangular and equilateral. And although it was equilateral, it was, that's still not right. Equilateral. There we go. It was hard to draw this. I had to adjust it a few times. If it was on paper, I would have to erase a couple of times to get it right. But instead of you guys drawing these, I gave you different tools to play with. So I'm going to switch over to my camera for a sec. Hello. So I have a bunch of big toothpicks here, and all the toothpicks are the same length, and I got these funky things to stick them together. And so when I built it this way, it was more obvious to me that it was equilateral, and then upon reflection, it's equiangular. Like, oh yeah, each of those angles at the top seems to be the same when I rotate it. Okay. So can you see the benefit of actually constructing geometric figures instead of just drawing them? Yeah, so that can be a big deal. So that was my first one. So we got some good things about it. Any other things you might say about it? You don't have to, but just any other thoughts on it? Somebody might reference the size of one of those angles, maybe. It's hard to talk about the length of one of the sides without measuring it, but can anybody have a guess at what one of those angle measures is?
60 degrees.
Oh, I got to switch back. Switch back. Yeah, 60 degrees. We talked about that a little bit last time. There we go. Okay. So, for example, that's another thing I could do here. Say, hey, this angle right there is 60 degrees, and so is that one, and so is that one right there. All right. So my next figure came from, switch again, similar idea. This is my second figure, and what might you say about it?
Square.
It's a what? A what?
It's a quadrilateral. Yeah.
So one pro and con of constructing it with real materials is on paper or on my screen over here, this sucker's like, it seems kind of rigid, right? It's got right angles. It's a strong square. But when I make my square in reality with many materials, come on. It's floppy. Look at it. It's floppy. Is it not floppy? Right? Check out my triangle. Is my triangle floppy? No? Emily, would be my volunteer here. Come on up. Confirm that the quadrilateral is floppy. Okay. How about my triangle?
Not floppy.
Pretty darn solid, right? So where do we see triangles a lot? Signs. Where else? What?
Ridges.
Ridges. Why would we use triangles instead of?
They're a heck of a lot sturdier.
Yes, triangles are sturdy. They're stable. Rectangular objects are not stable unless you build some kind of triangular brace in them. Okay, so that's super important. All right, so there's a benefit to looking at geometric figures on paper, but looking at them with real materials too. Okay, and weaving them is also a wonderful thing to do. So tell me some things about this right here. So quadrilateral is a good name for it. That's pretty general. Quadrilateral. Square came up first because I was really trying to make a square. Oops, square. But my square accidentally gets kind of floppy and turned into a rhombus, correct? Rhombus. Yeah. When it was a square, what could you say about it?
It was regular.
It's regular, yeah. Taylor, what's regular mean again? Yeah, equilateral and equiangular. How about a rhombus? It's not regular, but it is what?
Equilateral.
Equilateral. Yeah, it's equilateral. Equilateral. All right. All right, let's move on to my next figure over here. Anything? Oh gosh, I forgot to switch the video feed. Sorry, future people. I'll fix that later. All right, quadrilateral, square, regular, rhombus, equilateral. Okay, this figure down here. It's a pentagon. Yeah, you could say it's a one. Some you might say it's a 5-edged polygon. Polygon, which is another way of saying it is a pentagon. Okay. Anything else?
It's non-regular.
Yeah, it's definitely not regular. Not regular. And I'll show you the physical model, and hopefully I'll remember to switch video back. Just a quick button. No, so here is my original one. It's made out of 2 purple straws and 2 green straws and a blue straw. What can you tell me about the 2 purple straws?
They're the same length.
Same length, the 2 green straws? They're the same length, yeah. So when I made it, I'm going to switch back to my computer version of it. I tried to make it so this length and this length were the same length, this length and that length were the same, and then I have this oddball length right there. So usually when we're trying to say 2 lengths match up in their distance, we put a single dash to say those 2 match up and a double dash to say here's another set of matches. And you just keep making little slashes and so on. Okay. So when 2 lengths are equal, there's a word in geometry for that. That is true for like a triangle or a, what was the other word? Congruent was the one, or congruent, yeah. So I tried to give this 2 pairs of congruent sides, and then I just threw in a 5th side. Okay. So this has it has pairs of congruent sides. Pairs of congruent sides. Okay. And like my square, it's pretty darn floppy. Okay. Does anyone want to show off one of theirs? I would like to show off one of Ashley's, if that's okay. Could I have the metal one?
Sure.
Thank you. All right, let's show off the metal one to our video audience. Come here, video audience. There you are. Hello. So here is Ashley's metal shape. Let's see. Oh, here's the camera over there. Hi, camera. Okay. It's different than all of my shapes. What's can somebody name the biggest difference about this shape compared to all of mine? There's one thing I see as a big deal. I don't know if you guys see it too. It's got an indent, right? None of my other ones have an indent. Yeah, so that's an excellent point. I'm gonna draw this. And new page. So Ashley's looks something like bing, 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 something like that. Little points here, here, and there. Okay. So this is a polygon. Definitely. It's got many straight sides. That's what a polygon is. 1, 2, 3, 4, 5 sides. I should take away this dot right there. That doesn't really belong there. Let's steal that. Bye-bye. Okay. So this is also a pentagon. Because of that indent right there, It is a concave polygon. Concave. More specifically, a concave pentagon because it's got 5 sides. Pentagon. So if all of those are concave, I almost gave it away. Does anybody know what the word that's opposite of concave that applies to all of mine here? Convex. Yeah, beautiful. Yeah, these guys all over here are convex polygons. Convex polygons. Okay. Let's see. Some other shapes in the audience are here. Let's see. I'm on graph. Let's know right here, I think. That's and that one. All right, so here is another one. We built that over. And usually when I do this, I try to have all kinds of different kinds of things people can use to build stuff. So let's see, reverse background. So this reminds me of a truss, like for building a roof or a bridge, something like that. It's made up of multiple triangles. This has a huge difference than all of the other ones we've seen. What's a big difference about this one compared to the 4 we've seen so far?
It has defined shapes.
It's got stuff going on inside of it, yeah. So the other shapes I would say are simple polygons. This one is not simple, okay? And you have simple ones and not simple. This one's not simple because it has stuff going on inside of it. All right, let's see. What else? Got. Okay. All right, here's another one. So this one right here, what kind of shape would we call this? Rectangle, more general name for rectangle? Quadrilateral, yeah. So it's a polygon because it's got many straight edges. It's a quadrilateral because it has 4 straight edges. It's a rectangle because, why is it a rectangle? No, that's not, okay, so 2 sides longer is not what does it.
Because all the angles are 90 degrees.
All the angles are 90 degrees. That's what makes it a rectangle. Yeah. So to be erect is to be like perpendicular, and so that's why it's called a rectangle. That's not 90-degree angles. All right, what else do we got over here?
I have this big one.
Oh, okay. So it's this one. Oh, this is good. Yeah. All right, here's another one. So I'll write that stuff down in just a sec. So this one right here, one of our metal shapes. What do we call this sucker?
Hexagon.
Hexagon. Yeah, this is the hexagon. And is it regular? If we fiddle with it, we could make it regular. But at least if it's not regular, it's definitely what? Equilateral. It's definitely equilateral. We have to fiddle with it to make it equiangular. That doesn't happen automatically. But we can definitely make it, it's equilateral by design. Okay. But it's not made of triangles. So with these things, it's kind of floppy. It moves around a bit. It's got joints that wiggle. Right? So triangles have some wonderful physical properties. Ooh, that's a crazy shape. Wow. This is another example of a not simple shape. So what would we say about the triangle versus the quadrilateral surrounding it?
It's incised or something like that.
Yeah, what's the word for the triangle
Inscribed.
Inscribed. Yeah, so the triangle is inscribed in the quadrilateral, or the quadrilateral is circumscribed about the triangle. Yeah, circumscribed is the outside figure, inscribed is the inside figure. Okay, cool. Thank you for doing that. All right, so let's organize this stuff a little bit more. So we had another shape. That went inside of itself. I'm not doing it justice, but it did something like this. So this thing, it's a plane figure, it's a polygon, it's not simple. So a shape is not simple if it crosses over itself or crosses through itself. That's what makes it non-simple or not simple. Something that nobody made, which I think it's pretty common, nobody makes a shape like this, but check out this one. That's it. That's plane figure. We wouldn't consider it a polygon because it's missing a property for a polygon. It's not closed, yeah. So this sucker is not closed. Polygons are supposed to be closed plane figures, not closed.
It's not a polygon, but it is a plane figure.
Yeah, anything that lives in the plane is a plane figure. Yeah, anything we can make 2D. So I could try to make a semicircle to the best of my ability. And this is, it's just not closed. I could make a semicircle with a diameter. Circle, thank you so much. Diameter, and this one is closed. They're both plane figures still, because they're in a flat plane, which is mostly what we study in geometry. Oops. Are either of these polygons? Bottom one, it turns out it isn't because of the curve. Yeah, so if it's a polygon, it's gotta be just made up of regular angle lines meeting in angles. So this would be not, it's not a polygon. And with kids, we're not gonna give them definitions. We're just gonna start off by just naming shapes, okay? So I'm just gonna make kind of a family tree, starting with Polygon. So there's all different kinds of polygons, and we classify them by side. So we have our triangles, right? And there are special kinds of triangles, like right triangles. And there's isosceles triangles. There's scaling triangles, and there's tons of different kinds of triangles. I'm not going to list all of them, but there's some different kinds, and you can mix and match often too. So polygons are also quadrilaterals. So let's see, what kinds of quadrilaterals do we know? Squares, one, yep. What else? Let's don't put it in yet though, because we're going to put it in a special place in the tree. We got squares, we got rectangles. What else? Those wouldn't be quadrilaterals because they have more than 4 sides. Yeah, so those would be moving along the polygon family tree, but they're not in the quadrilaterals branch, right? So other kinds of quadrilaterals. Rhombus, yeah. Trapezoid. Starts with a P. A. R. E. L. Parallelogram. I think I get those letters in the right order. Let's write them down and see. So the next kind of quadrilateral we can define in the family history here would be, I would say, a trapezoid. Trapezoid has a couple of different definitions. Often it's having a pair of parallel sides. And then the question is it only one pair, exactly one pair, or is it at least one pair? Okay. So I usually go with the at least one pair. If we define it that way, then a parallelogram is a special kind of trapezoid. That's not the main reason I like that definition, but it's kind of cool that way. So parallelogram. So can you tell me some other parallelograms? Is a rectangle a parallelogram? Yep. Parallelogram with right angles. How about a square? It's a rectangle too. So that comes straight off the rectangle family. Okay. Let's see. Is a rhombus a parallelogram? Okay. Is a rhombus a rectangle? No. So it has to come off parallelogram, but not that. So rhombus. Is there any relationship between a square and a rhombus?
A square can be a rhombus.
Yeah, a square is a rhombus with right angles. So we can go from rhombus to square in the family tree. Square can either be evolved from a rectangle. Rectangle is equiangular, right? If we make it equilateral, we get a square. Rhombus is equilateral. If we make it equiangular, we get a square. So that means a square is what kind of quadrilateral? If it's both equilateral and equiangular. It is, or yeah, square is a regular quadrilateral, right? So there's all these connections. There's different ways to define them, okay? And the best way to start playing with shapes is to just, hey, give them a name and then let the kids discover how they're related. Okay, so we're speeding through this. Usually we do a lot of play with shapes and talk about their qualities. And eventually kids say, oh, look at that. A square is like a rhombus, but it's got right angles. Okay, so it's kind of a discovery thing you can do. Some other shapes, from quadrilateral, we have pentagons, hexagons, and then we can just keep going, adding more sides and more sides. Eventually, we just stop getting fancy names for them. Like, anybody know what a 12-sided polygon is called? It could be just called a 12-sided polygon. It's called a dodecagon. Do is 2, dec is 10, 2 and 10. But often we just call them n-gons. So you could call it 12-gon. There's polygons with 48 sides. What do we call it? 48-gon. Could you give it a specialer name than that based on like Greek, Latin stuff? Sure, you could. But most of them don't have those special names. So there's n-gons that we can play with. All right, let's see. A couple other things, and then we're going to be good for today. It's going to take another day to get through this section. We got quite a bit of work to do. Yeah, I want to take a look at activity 3, I think. Is 3 what shape am I or something like that?
Name that polygon.
Name that polygon. Yes, yes, yes. Thank you. Name that polygon. So where's mine? Here it is. All right. So we're going to try and name these polygons together. Oh, okay. So far we're going to do 3. But not 1 and 2. And probably not 4. But maybe 5. 5 is likely. We'll see Wednesday. We're not doing 1 and 2. We're likely to do 6. We're very likely to do 6. That's high on my list. 5 is medium. 5 is a maybe. Wait a minute. Okay. 4 is a no. 5 is a high maybe. 6 is a definite. 7's a high maybe. Yeah, so 3 for sure. Okay. So a 4-sided polygon with exactly 2 right angles. So think about that. Maybe do a little sketch. Right, exactly 2 would be no more than 2. Yeah. 4-sided. So there's a possibility. You're supposed to, somehow you got to figure out what this is. Can we name this polygon? So someone described the polygon for us and we're trying to name it as best we can. So I'm just kind of sketching 4-sided figures with 2 right angles. A rhombus does not necessarily have right angles. If it does have right angles, what would we call it? A rhombus with right angles? A square. Yeah, so a square is a polygon. Oh wait, exactly 2. Yeah, so that's too many. So the way I drew this right here, it looks like these might be right angles too. And so that might be out. What's this figure right here? Does this sucker here have a special name?
Trapezoid.
Yeah, if you turn your head sideways, it's trapezoid. Because this right angle and that right angle makes this side parallel to that side. To show sides are parallel, we usually put an arrow going in to show the same direction. Yeah. So this is a trapezoid. That's a possible name. But here's the question. Are there shapes we could draw based on this description that aren't trapezoids? I challenge you to use that description to draw a shape that's not a trapezoid. Yeah, so what did I do that forced this to be a trapezoid in the way I drew it? Okay, what else did I do before I did that? Because I actually extended that line a little to make that happen. Because I realized if I didn't and I went straight across, I was drawing a rectangle, which I couldn't. I made the 2 right angles first, right next to each other. Question, do the right angles have to be next to each other? No. Okay, so draw 2 right angles that aren't next to each other and see what happens. I tried doing that here, but what did I assume when I did that?
Oh, yeah, just for the same thing.
No, I wasn't really trying to make the edges the same length, but I did kind of, in my head, I wasn't even thinking about it, but I made this side parallel to this side here. Is it possible that I could make a right angle where this side isn't parallel to that one? And I'm still going to get a shape? That angle might be too extreme. What if I made that my right angle, and then I extend this side, and I extend this side, and I extend this side? Does that leave me with a 1, 2, 3, 4-sided figure with exactly 2 right angles? What do we call that shape? A 4-sided polygon with 2 right angles? I think we call it a 4-sided figure with 2 right angles. So one possibility is a trapezoid, and then another possibility are weird things like this. Quadrilaterals with only 2 right angles that don't have a name yet. We could try and name it. Be a good name for that. Let's see.
A Parker square.
A what? A Parker square. It's not that square.
Parker Polygon.
I don't think it deserves Parker.
It doesn't take your name.
Okay, we'll come back on that for a name. Okay, let's try another one. Next one said an equilateral quadrilateral. An equilateral. So what's our answer for number 1?
Trapezoid.
A trapezoid? Maybe, maybe not. Right? Because we did come up with a quadrilateral that had exactly 2 right angles. That doesn't have a special name. Yeah. Yeah. So So just because you come up with a definition doesn't mean somebody already came up with a special name for it, you know? An equilateral quadrilateral. What do you think that could that have a special name? Equilateral, no, because a rectangle isn't necessarily like Taylor's rectangle was not equilateral. Yeah, this says equilateral, right? Yeah, equilateral.
A square or a rhombus?
A square, yeah, it doesn't say it can't be equiangular, so it could be, yeah, so a square or a rhombus. But check it out, isn't a square already a rhombus? So we could just say a rhombus would be the best answer here, I think. All right, this is too much fun. Let's do one more. Oh, you guys just thought that. Did anyone draw a picture or did you just thought it? Wow, you guys are awesome. I usually have to draw pictures. An equilateral quadrilateral with one right angle. Ooh. An equilateral. The toys might be helpful for this and playing around. Equilateral quadrilateral with one right angle.
It doesn't say
Baseball.
It doesn't say exactly one angle. It doesn't say at least one angle. So it's a little vague there, yeah. So I think some people might insist, no, it just says one, but it didn't say it can't be more, right? The other one said exactly two. So I think we could err on the side of, like, you know, our legal system does, vagueness can mean many things. What's that? It's a quadrilateral, so it's got to have four sides. Got to have four sides. So this is one of my favorite programs. It's called GeoGebra. So I'm going to make myself a polygon. So let's see. It's equilateral though, so I got to have them all the same length. How do I do that in GeoGebra? I start there. Ooh. Oh, it wants to complete it. Okay, escape. Let's make a line segment and then a circle.
Couldn't you just copy that?
And then I can put a point on the circle somewhere here. So if it's on the circle, these are both radiuses, so they have to be the same length, right? And then I want to come off there, so I just make another circle to measure with. And I could put any point on here, couldn't I? Maybe put it over here. Here's another line segment. And then boom, I now have a quadrilateral, right? A, B, C, D. But one of them's got to be a right angle, right? So couldn't I fix it so this is the right angle here if I wanted to? It's pretty close. Let's see, there's an angle measure button here. Let's see, which way do you go? This way to measure an angle? Yep.
How would that side be? There's a equilateral.
Oh shit, it's not equilateral.
Well, unless if you.
You're right, I gotta fix that. Yeah, I messed that up. Okay, so I got two things to fix here. So to make that happen, I need to connect the circle from here to here. And then I would have to move this so that circle coincides right like that. So these are all the same length. And then I want this to be a right angle, so I got to move this point so that's too big. Oh, there we go, 90 degrees. You can't see it, but 90 degrees. Okay, so if that's 90 degrees and these all these are all the same length, and I'm just guessing at that. Let's measure some other angles, see what happens. What is this angle up here? 89.7. This one is 90. Oops, I went the wrong way. I think that's right. That one is 90. Oh. However, I kind of messed up that last point, didn't I? I didn't exactly put it in the right spot. Huh. So what do you think? It's probably a square. Yeah, that one, because it's equilateral, one right angle forces all the other ones to be right. So think about that. Didn't you guys, some of you have toothpicks or maybe those little metal plasticky rods? Try making, those definitely you can make an equilateral quadrilateral. What happens if you try to make one of the sides, one of the angles a right angle? What happens to all the other ones? It's pretty much forced into it, isn't it? Yeah.
Can one shape be more than one? I'm like,
Can one description be more than one shape?
Yeah.
There's usually a best name. Which one were you thinking about?
I don't know, I was just asking.
Yeah, so I think like over, where'd it go? Where's my notes? With this one right here, we said a rhombus or a square. So I'm just gonna write down or a square. But then I was like, well, a square really is a rhombus, so the rhombus is the best name for this. So I think there's probably, if there's a name, there's probably a best name. Yeah. All right, so we're gonna stop there. Class time is up. We'll pick up with this activity. And then if you guys still have any more questions, if you didn't finish the things you find in a paper circle, and we still have a bit of work to do to get done with section 3. We're about halfway done with section 3.